We've all seen AI do some pretty incredible things, right? Pulling answers out of this just massive ocean of data. But here's a question. What happens when the answer isn't one shiny pearl sitting on the ocean floor? What if it's scattered in pieces all over the place? Well, that's what we're diving into. This is about the next major leap for AI, moving beyond just finding stuff to actually understanding how it all connects.
I mean, you've totally been there, right? You ask a chatbot what seems like a super simple question. One that just requires connecting two little dots, and it just completely whiffs. It's frustrating. So why is that? Why do these incredibly powerful systems still fail at tasks that seem completely obvious to us?
Okay, let's get specific. Imagine an AI reads two sentences in two totally different documents. One says, Ben Silbermann was hired at Google, and the other says, Pinterest was founded by Ben Silbermann. Now, for you and me, connecting that is instant. No problem. But for a standard AI using what's called Retrieval-Augmented Generation, or RAG, that's a huge challenge. If the facts aren't sitting right next to each other, the AI just sees two separate puzzle pieces. It can't see the big picture.
And that really gets to the core of the problem. Traditional RAG treats knowledge like this giant, disorganized pile of books. It's gotten really good at finding the right page, but it has absolutely no idea that a character mentioned on page 12 is the exact same person who makes a big discovery on page 347. It's completely missing that web of connections that makes up the real story.
So, okay, how do we fix this? We have to trade in that messy pile of books for an organized, logical web of understanding. And this is where the hero of our story comes in, the knowledge graph.
So what in the world is a knowledge graph?
Well, it's not just a database of text. It's a network that actually understands things. People, places, ideas. These are what we call entities. And here's the magic trick. It explicitly maps the relationships between them. It doesn't just store the words. It actually understands how they're all connected. Think of it this way. Forget the stack of books. A knowledge graph is much more like a dynamic mind map. It's a structured, visual map of how every person, every company, and every idea is linked together. So let's go back to our opening problem. With a knowledge graph, the AI isn't just looking at text anymore. It's seeing structured data. It creates a little bubble or a node for Ben Silbermann and connects it to a Google node with the relationship worked at. Then it connects that same Ben Silbermann node to a Pinterest node with the relationship founded. And suddenly, the path is crystal clear. The question gets answered flawlessly.
Now this all sounds fantastic, doesn't it? Let's just turn all our text into graphs. But you knew there was a but coming, right? Of course, it is not that simple. Building a truly intelligent and reliable knowledge graph from messy, real-world text, well, that comes with its own set of very serious challenges.
And here is the big reality check. It's one thing to build a perfect graph for a neat little controlled demo. It is a whole other beast to build one that can handle the chaos and ambiguity of millions of real-world documents and not just completely fall apart.
And one of the biggest hurdles is cost. For standard RAG, if you want to turn a book like The Wizard of Oz into vectors, which is basically just numerical representations of the text, it costs next to nothing, a fraction of a penny. But to have an AI read that same book and intelligently pull out every character, every location, and all their relationships, that is a far, far more complex and expensive job.
So to manage all this complexity and cost, you need a blueprint. And that blueprint is called an ontology. The easiest way to think of it is as the rulebook for your knowledge graph. It defines what kinds of things are allowed, like person, company, or drug, and what kinds of connections can exist between them, like worked at or treats. It's what brings order to the chaos.
Okay, so with this idea of an ontology as our guide, we can now move from just talking about theory to seeing how these advanced, structured systems are actually being used to solve some incredibly complex problems. So let's quickly compare the different approaches. You've got your standard vector RAG. It's fast, but it's totally blind to relationships. Then there's the basic graph RAG. It's definitely smarter, but it can be a messy, expensive beast to manage. But an ontology-guided approach, that gives you the best of both worlds. Incredible accuracy and a huge reduction in those weird AI hallucinations. The only catch is you have to do the work up front to design that blueprint, the ontology.
So where is this kind of technology a real game changer? It's in high-stakes fields where close enough just isn't good enough. Think about finance, legal research, and medicine. Domains where a single mistake or a bit of ambiguity can have massive consequences.
Take the biomedical field. Researchers there are using a system called Ontology-RAG.
and it translates a doctor's normal, plain English question into a super precise, structured query for a database. This massively accelerates research and slashes the risk of error, which is absolutely critical when lives are on the line.
And the systems being built today are unbelievably sophisticated. They're not just using one simple graph, no. They're creating these complex, multi-layered maps of data and using all kinds of advanced algorithms to navigate them. But here's the most important part. Every single connection in that graph links directly back to the original source text, which creates a verifiable audit trail for human experts to check.
So what does all of this mean for the big picture? Where is this all going? Well, this isn't just a small improvement. It's a really fundamental shift in how AI interacts with information. What we're really seeing is this shift from simple retrieval to genuine reasoning. The goal isn't just to build a better search engine anymore. The goal is to build an AI that truly understands the context, the connections, and the very structure of knowledge itself.
Of course, with this kind of power comes great responsibility. Experts recommend a really cautious approach, using hybrid systems and constantly checking for bias. But two recommendations really stand out. First, always require a human to sign off before new knowledge is added to the graph. And second, create a full audit trail. The key takeaway is that even in this automated future, the human expert has to be the ultimate guardian of truth.
And that leaves us with a final, vital question. As we build AIs that can construct their own vast networks of understanding, ones that go far beyond what any single person can hold in their head, the challenge shifts. It's no longer just about finding the right data, it's about validating the very foundation of the knowledge that it creates. So how do we ensure that this new, interconnected intelligence is building its world on a bedrock of truth?